Good morning friends, welcome to this Python tutorial, and our topic for today is sets. As a continuation, I told you there are four types of containers that we have. We have a set, we have a list, we have a dictionary, and we have a tuple. So all of them are used based on the purpose we need to satisfy. So today we are going to talk about sets. So as you may have learnt and seen that in mathematics also we had a similar concept of set. So here also we have a similar concept, and they almost share the same functions and features. So what is set, you may be thinking? A set is an ordered collection of data types that is alterable, mutable, and has no duplicate elements. So what you may be thinking, this is long term and has many things. So it's like unordered because you can't uh, order it one after the other. It doesn't contain duplicates. Okay, now when you see a set, you'll see that there is no repetition over there, so that's the best part. And it's mutable, so like we have learned earlier, so that tuples are immutable. So that cannot be changed once created, but here they are mutable, so they can be changed. And the best part is, they, as I told you, they don't have duplicate elements, so it can be used over there. The advantage of using set is over list is that it is highly optimized for checking whether a specific element is contained in the list or not. So there's another type of set, a subcategory of a set, you can say, that's called a frozen set. So they are like immutable, so they are once created, so they won't be changed. We will be seeing them in this, a demonstration of them in this video also, and how the sets appear. So let's get started. So first we'll be creating a set. So let's check how to create a set. So it's like we create se1 is equal to set, and it has 1 comma 2 comma 3 comma 4 comma 4. Okay, now when we create this, now sc1, now you see all the repetitions over here have been, like we repeat it, we try to repeat 4, and now when we print 4, when we print it, all the repetitions, as I told you, will not be there. They are declared using two brackets, double brackets. One more way how you can declare them is, 1 comma 2 comma 3 comma 4 and SE2. So you can check the type of SE2, and oh sorry, TY PE SE2, and yeah, as you see, so there are two ways. One is using the set itself, and the other like this. Let's see if you can do it without SC3. We'll be using this set, so it's not like set uh, we'll be creating a set of numbers, like, shall we take names? We'll be taking names. Karan, Kar, and Ram, and you see you get an error because is expected to have at most one argument. So this is the error because, see, here you haven't used, this is one argument you have to, so when we are doing this, we are only showing them one argument, we're not giving them two arguments. So this is how. Now let's try it using the same example, and but now we'll be, and SE3, and you see you get a set over here. Similarly, let's create a frozen set, sc4 dot is equal to frozen set, and here we print A, comma B, comma C, comma, yeah, that's enough. Now let's see SE4. Okay, it specifies us because it's a frozen set. Now I'll show you the use. Now you may be thinking that this and this are similar in terms of the type, but there's a bit of difference, and we'll be seeing them soon. So let's get started with some methods that can be applied to sets. So what if we want to add something? So let's see set 3 se3 dot add, and we add se3 over here. Naman. So se3 becomes number also. Okay, now let's see if frozen set can be performed with the same thing. Now se4 dot update dot add, sorry, add d. We don't have a d in, right? So now when we do this, see, it gives us an error because it's a frozen set, so it can't be, we can't add things over there. So now let's create a se5 to demonstrate you the next function. So 5 comma 7 says comma 9 use this comma 6 and comma 2 comma 3. Okay, now C5 would give us this. As I told you, there would be no repetition. Now let's use union between set C1 and SE1. So SE1 unit SE1, and then we'll be using a union of 2. So dot union and SE5. So what we get now, so here as you can see, so what union does, it gives us all the elements, whether it be in SE5 or in SE1. So it's like include everything over here. I don't want to miss anything. So in a real world example, like it's a small kid who wants to take everything. Now let's see, you can operate the same function using something like SE1. This is our uh, straight line, a pipe, SE5, and see, we get the same function. So both of them, either of them which you are comfortable with can be used. So SE, now let's see, like these are the ones which are in both. Now what if we want to find the ones which are in common in both of them? So what will we be doing in that case? So SE1, so that's called an intersection, if you remember, intersection, and that's the SE5, and see, so 2 and 3. Similarly, as I told you above, we have this over here. We also have a similar function for this, and that's the AND operator. So the AND operator can be used over here. You can also say it as the bitwise AND operator, SE5. So you can see the same results, we are getting the same results over here. So what if we want to print something that's present in set 1 and it's not present in set 2? So it removes all the ones that are present in set 1, and but it should not be present in set 2. So it's a bit, if you have done already sets, you would might have understood it what I'm trying to say. it's called the difference method. And similarly, as I told you in the above section, that we have two methods for them, here also we have two methods. So two methods for the same thing, two ways, basically we can say that two ways to operate the same thing. So let's do that. So SE1 and dot PIFAVRENC difference and SE5. So 1 and 4. So it will give us all the elements that are in one, and here, yeah, so you see over here, these all are the ones. So it will give us all the elements that are in SE1, but should not be in SE5. So 1 and 4 are not over here, and 2 and 3 are over here, so they are excluded. Now similarly, I'll show you the process if we do the opposite thing. SE5 dot AIFFERENC and SE1. So here we get the remaining ones, like 8 8 we get 8, 9, 5 and 6 over here. 8, so 2 is over here, so we won't get that. 3 is over here, so we get 8, 9, 5 and 6. So that's what I was talking about. Now one more thing I would like to tell you, that this is how the difference works, right? So now you can do the similar thing using a minus sign also, so that's an easy one. And it's most often used SE minus SE5, so it will give us the same result as above, and similar for SE5 minus SE1. So it says, it should be read as, give me the elements of the set that are in SE5 and remove those which are in SE1. So this is how we say them, the difference. Now, as we have seen earlier in our previous sections of list and dictionaries, like we use the clear function. So SE5, like suppose we want to clear the frozen one, so I'll show you how to do the SE3 and SE3 dot clear, and it would see, it would not remove the entire set but all the elements inside it. So this is done through, now you would be saying, let's do for the frozen one. Does it work for the frozen one? So we have the frozen one named SE4 dot clear, and you see the frozen one can't be altered, it would be directly deleted. So delete SE4, and SE4 now see doesn't exist, so we have a delete also. So as you see, delete is for mostly all of them. Delete function works everywhere. Now let's check how to calculate the length. The length over here is calculated by SE1, like let's calculate. So it's 4, length of SE5, you see. So this is how we calculate the length. Now let's see if we can access elements in the list like we did it in case of index. So you would be surprised to know that, like, we want to access the second element. So you see, because it's not an index, it's not an ordered list, so we can't see that we have the number coming up. So we have other way, using the for loop for I in say set1 and print I, print I, and let's see what we get. So see, we get all the numbers in our in our set1. So we have another thing to check if this is present. This like if you want to check if something is present or not, so like we say 2 in I, 2 in SE1, so true, but let's say we have 9 in SE1, so false. So 0 for in SE false, in SE2, and we get a false. So this is how we do. Now let's see, we have seen how to check add elements. Now let's see how to remove them. So like SE, now let's take something else. Now let's take SE3, SE3, and we'll be deleting Naman. SE3 dot remove Naman. Remove Naman keyword key error. Let's check what's the error. So SE3 would now give us all the elements. Now as you saw above that, since an element was not present, so it gave me an error over there. Now let's see if I want to remove. Now we won't be using remove over here, we will be using discard over here. So discard se3 dot discard Jatin, Jatan se3. So you see Jatin was not there, so the difference is that this gives us an error, this doesn't give us a warning, and the other piece we returns us a warning. So now let's pop current or from this se3. Okay, se3 dot pop, so RAM gets pop out. So you don't know, okay, from which side, because it's an unordered list. So while using pop, you don't know which element would be popped out, and that's why we can't estimate beforehand. So pop would not be a intentional one. If you want to remove items, then pop can be used. Let's see, copy dot copy, and let's store it in SE6. So SE6 would gives us, and it's also set, so no issues over here. Let's see, like earlier, like we were doing, does it have the same thing? SE6 is equal to SE3 is equal to 3 equal to SE6, SE6 SE7 is equal to SE6 SE7. Okay, now let's pop in SE7 dot pop Gopal. Now see, does it affects SE6 comma SE comma SE3 current. So as I told you, copy is a different thing, and here is the other thing, like the when we create a copy, it's a different thing, and we assign it, it's a different. Okay, now last function for the day. Now let's check if se3, now we can check if something is one of the set is a subpart, or comes under, if contains elements of some other set. So how to check that? So as you can see over here, that we have an SE3 SE. So let's create SE3, let's edit SE3 right now. So SE3, and copy it up from above. So SE3 now has this much. Okay, and SE6, as I showed you, has current. So SE6 dot is subset of SE3 true, because current over here, as you can see, is included in SE3. Now similarly, if you want to check that SE3 is a set. Now the ones which contain all the elements are called the supersets, and which contains a part of it is super superset. Okay, super set, and then we write as e1 se6, sorry, and then we see it's true. So this is how things work in sets, and I've explained all the functions and operations that can be done in sets. So thank you for time being, and I hope you enjoyed the video.